what we're looking at here today is this thing called composite areas, okay? You might have heard of this word before. When we think about composite areas, all it is we're looking at shapes which have been combined using other shapes. The way I like to think about it is think back to your Power Rangers, right? You have all these individual Power Rangers, maybe like the red one, the blue one, that pink one that everyone liked, and then you combine them together and you form this like super Power Ranger, right? And that's kind of what these composite areas are like. We've got all these individual shapes here. We know how to find the areas of. We've got a square, rectangle, and triangle. But how do we combine them together and form our composite shape, right? When we're doing these, we want to think about two things. We're either going to be using addition or subtraction. Okay, addition or subtraction. In this one here, Harry, when you're looking at this shape, what kind of shapes can you see inside?
I can see a rectangle.
You can see a rectangle and a triangle. Okay, so often there will be many ways we can divide up these shapes. In this one, I think a really easy way to do it is to see that there is a rectangle and there is a triangle. So I'm going to literally just drop a dotted line there so I can see that. Often what we'll do is I'll call this one area 1, A1, and this one area 2, A2. Now I want to find them individually, and then like I said, in this case, I'm going to use addition to find their total areas, right? A1, Matt, how would I find that?
3 times 14.
3 times 14, right? Because it's a rectangle. I just want the space inside. I use 3 times 14, length times breadth to find that. What's that going to be?
That is going to be 42.
42. A2, Harry? How do you find the area of a triangle?
1/2 times 4 times 4.
Yeah, because you know that these lines mean that these sides are equal. So 1/2 times 4 times 4. Right, and that's going to be 8.
Yeah.
Nice, well done. What's the last step I got to do?
Also,
Add them together, right? Because in this case we're using addition. I want to find the total area there. A1 plus A2, that's going to equal to 42 plus 8. So 50. Is that my final answer?
no.
No, what am I forgetting?
Meters squared.
Right, square meters, right? Because remember, in measurement, we always need to have units. So the area is equal to 50 square meters. Okay. Want to try another one? Now, we can get other types of composite shapes. In this case, I can still see multiple shapes there, but you notice, I'm trying to find the area, right? It looks like I've got this square here, and I've just kind of cut a hole out of it. In this case, I don't actually want to use addition. What do I have to use instead? I want to use subtraction, yeah. So I'm just going to make a little note of that. Whenever I'm answering these composite area questions, I want to think, am I using subtraction or addition? In this case, I'm using subtraction because you can see I've got that square here and just cut that hole out of it. What shape can I see again in this one?
Oh, well.
2 squares, right? I can see 2 squares. I can see this big square, and I can see this small square. Again, we can use a similar kind of practice. I can use these names to help me find these areas of the things individually, and then rather than adding this time, I'm going to be taking things out. So let's say that this big one, we'll call it A1, and that smaller one, we'll call it A2. Now, what's A1 and A2 going to be?
What's the area?
What's the areas, yeah.
Okay, well, A1's going to be it would be like the whole square minus A2.
So okay, maybe if I think about it in the A1 is, I'm thinking A1, if I draw it individually, it's a good question. Yeah, so A1 would be this guy here, right? 7's all around. And A2 would be this smaller guy here, right? Does that make sense?
Oh, yeah.
Yeah. So I'm looking at them individually. I'm trying to forget that there's like a hole there at the moment. I'm just looking at them
So then,
individually.
A1 would be 7.
Yeah. So 7 times 7 or 7 squared,
So that'd be 49.
49. And A2?
Millimeters squared.
Yeah, I'll put in the units at the end. Yeah.
And then
What about A2?
That is 4 times 4.
Which is, yeah, 16, nice. So 16, right? So can you see how it makes it a bit easier, rather than thinking, oh, it's a bit confusing because there's this hole cut out of it. Why don't I think about the big one individually, the small one individually, which are a lot easier, and then bring them together at the end. So I said that, in this case, I want subtraction. So I've got this big one here, and I'm literally, what I'm doing is I'm cutting a hole, which is size A2 out of it like that. So that's where this guy goes.
49 minus 16.
That's right, yeah. I want A1 minus A2, or 49 minus 16, which is
33.
33. Yep, checks out.
Oh, highly squared.
Nice, well done.
Meters squared.
So again, yeah, total area, careful with the units, is 33 square millimeters.
Yeah.
And that's it, all you're gonna do. Think about whether you use addition or subtraction. Think about what shapes you can see. That's how you can answer any composite area question.